Okay, so now we're at part 2, and we're going to, what have we reduced Dave's problem to?
All of the numbers which have exactly 2 rows of divisors.
All the numbers that have exactly 2 rows of divisors, it looks like. So we gave an example of 15, which was 1 and 15, and then 3 and 5.
Well, I think you're going to need, for a number x, when you write it in like this form, you're going to need, you can have only 2 prime powers, and the powers have to be to the 1.
Okay.
Interesting.
So I'll just do p1 to the 1 and p2 to the 1,
Okay.
and then times 1.
So 10 was 5 times 2, 15 was 3 times 5.
Interesting.
Okay.
What
Now
is
give me another example.
Well, ones that have this.
Well, ones that form you're
Well,
talking about.
6.
Alright, go ahead and write it out.
2 times 3.
Ooh, 6 is an interesting one.
Yeah, 6 is, it's 1 times 6 and 2 times 3.
Yeah, 6 is interesting for another reason, actually, when you do... What was that?
The dresser, I think, opening up there.
Oh, okay. When you multiply the products together, you get 6. What do you get when you add them together?
6.
That's interesting.
Mm.
But
Okay.
that doesn't work for all numbers.
Certainly not. Okay. So what do you think?
Maybe we can do it both. Maybe we can use it both ways. They have to have exactly 2 rows of divisors, and they have to have 2 prime powers.
Okay.
So they have to be to the 1.
That's a very interesting observation. Having exactly 2 rows of divisors and having exactly 2 primes going into them to the first power are 2 different conditions. Okay? So we said all the numbers with this property are going to have 2 rows of divisors. We reasoned through that.
Yeah.
Right? Now you have said this is an example of a number that's going to have 2 kinds of divisors, exactly 2 rows of divisors, but is it all of them?
Yeah.
So, if we made all numbers that work, is this part here with 2 primes a little piece of it? Or is it the whole thing? Because it does say describe all numbers. So I think he wanted to make sure. He didn't say just find some of them or give me one example, right? He said I want to know all of them.
Well, let's...
But so before we move on, do you understand that this alone might solve the problem? Or it might not solve the problem. It might not be all of them.
There might be more bits.
There might be other bits. Looks like a skull on its side. Ooh. Okay. So we found some examples like this. 10 was an example that had 2 primes. 15 was an example that had 2 primes. 6 was an example that had those 2 primes. And that seems to be a pretty good solution.
Yeah.
Now, you've spent some time in the last month or so studying number theory. If I have a number who has a product of 2 primes, prime 1 to the 1 times prime 2 to the 1, how many divisors does this have in total?
Well, you have 2 choices for prime 1. You have prime 1 to the 0 and prime 1 to the 1.
Right.
You have prime 2 to the 0 and prime 2 to the 1. So you have 4 divisors.
You have 4 divisors, just what we were hoping for,
Yeah.
right? All right. High five. Okay. High five. All right. Now, so we've at least partially solved the problem.
Yeah.
Now we got to figure out, are there more bits to it, or is this the only one? Okay.
Yeah.
How are we going to do that?
Well, we could try an example where this doesn't work, like 20.
Okay. Well, Actually, that's a good idea. Let's move to the next video.
Okay.